All right, so we're going to go ahead and start looking at radicals and simplifying radical form. And this is just part 1 for today. All right, so what is simplified radical form? Okay, now that is just the radicand of the nth root contains no nth powers or as factors, or the root index is the lowest as it possibly can go. Okay, and now what's also important for this lesson is that we can go from radical form to exponential form and convert it back and forth between the two. And when I say that, radical form starts off with n in our index. Okay, our radicand would be this value or base on the inside. That's our radicand. Okay, and sometimes it's to an exponent, let's say b. Okay, now that's going to equal a to the b divided by n. Okay, and so we can convert between the two. All right, I'm going to try a different stylus here. Still trying to figure out what works best. All right, so let's go ahead and talk about simplifying radicals. We're going to start with example 1. Now with example 1, we have 288. 288, we can go ahead and break down, and we're going to go ahead and factor 288. And the way that we're going to do that is first, I've noticed that it is even, so we can always divide out a 2. So I'm going to go ahead and find the factors, and I'm going to pause the video and I'm going to go ahead and factor this entire thing out. All right, now that this has been entirely factored, what I'm going to go ahead and take a look at is at only the prime numbers. Okay, the prime numbers are on the very end. What we're going to do with that is we're going to look for groups of 2 numbers that are the same. So we've got one group of 2 numbers that are the same, another group of 2 numbers that are the same, there's another group of 2 2's, and what's left over, that's going to be left inside as a radicand. There's no other prime numbers. Okay, so our groups, we can break them out because we can say that the square root of 4 is 2, and we know that for a fact. Okay, a group of 2 numbers added multiplied together gives us just 2. The square root of 9, that's 3 times 3, which is going to be 3. So in this case, we have 2 times 2, which is going to just end up being 2. That's going to go to the front of the radical. So 2 times 2 times 3 times the square root of 2, because this last number, it's leftover. There's not another number to multiply it by. So we're going to go ahead and simplify. So we're going to end up with 2 times 2, which is 4, 4 times 3, which gives us 12 square root 2. And we're done. That's our final answer, our final simplified radical there. Okay, and there's nothing else to simplify. All right, so let's go ahead and take a look at example 2. Now the difference with example 2 that I notice is the fact that we end up with a 3 for our a index. Now that index tells us the number of the group of numbers that we need. Okay, so if it's 3, we need 3 numbers that are the same. So let's go ahead and take 16 and factor it down. I'm going to change that line. So that's going to end up being 4 times 4, which can also factor 2 times 2 times 2 times 2. So if I were to rewrite that, that would be 2 to the 4th power. Okay, but in order to simplify that, we really just need 3 numbers that are the same. So I'm going to circle 3 numbers, 3 2's. That's going to all simplify down to the cube root of 8, which is just 2. That goes on the outside. Your index stays in the inside, and we're left with 2 because we have one remaining 2 that doesn't simplify out. All right, now let's go ahead and take a look at our next example. Now our next example kind of brings in together 2 concepts. One, we simplify the radicand and see if we can simplify any groups of 3 numbers that are the same and bring it on the outside. Now we cannot combine these yet until the radicands are the same. Okay, just like you wouldn't combine x plus y, we can't do that here because they're not the same values on the inside of the radicals. All right, so let's go ahead and take 2,187. Okay, 2,187. Now I noticed it was not even, so I'm going to go ahead and try to see if a 3 divides out, and it does. So it's 3 and 7, 29. Okay, 729, that's also not even, so we're going to end up continuing to divide out a 3. So it's 3 times 243. Okay, continue to divide out a 3. 3 and 81. 9 and 9. 3 and 3, 3 and 3. So that's a lot of 3's going on. Okay, and we're looking for groups of 3. So what I'm going to do is I'm going to go ahead and circle this group of 3 3's, this group of 3 3's, and we're left with one remaining lone 3. Okay, so that's going to stay inside the radical. So it's going to be 3 times 3, which is going to give us 9 on the outside, cube root 3, minus, okay, we got to take 27, or I'm sorry, 24, and we're going to go ahead and factor it out. That's 2 times 12, 3 times 4, and 4 breaks down 2 times 2. So we're looking for numbers of 3 of the same number, which in this case is just 2. So 2 goes on the outside times 2 from simplifying all of that. The cube root of 24 is just going to simplify down to our lone 3 that didn't have a group, 2 others to be able to simplify out of the radical. And what we're going to do now is we're going to go ahead and simplify the coefficients. This 2 times 2 needs to be simplified, so that's just going to be 9 cube root 3 minus 4 cube root 3. All right, now notice how the coefficients, we have 9 and we have negative 4. Okay, 9 minus 4, that's just going to give us 5 cube root 3 as our simplified answer. Okay. All right, so example 4 is very similar, but instead we're looking for groups of 4 numbers that are the same. So we're going to go ahead and take a look at 32 and 162. I'm going to pause the video right here, factor those values out, okay, and find those groups of 4. All right, now we're looking for, now that I've factored out both of those numbers, I'm looking for groups of 4 numbers that are the same. Okay, so let's go ahead and take a look at 32. Looking at 32, I can go ahead and circle this group of 4 numbers that are the same, and I have a lone 2. Okay, so this group of 4 numbers that are the same, they're going to go on the outside. Don't forget your index, okay? And then our 2 goes on the inside of the radical. Left with, okay, 5 is going to come on the outside because that's our coefficient that is already there. Whatever we simplify, that's going to go on the outside and be multiplied with 5. All right, so we're looking for 4 numbers that are the same. In this case, it would be 3. Okay, so 3 would go on the outside, the 4th root, and then what our remainder is, our remainder for this problem is just going to be 2. Okay, next step is to go ahead and simplify. So that's going to be 2 4th root 2 minus 5 times 3, which is 15, the 4th root of 2. Okay, now our radicands and our indexes are the same. So what we're going to do next is we're going to go ahead and combine the coefficients. So 2 minus 15. 2 minus 15 gives us negative 13 in the 4th root of 2. Okay. So at that point, you've completely simplified. The index and the radicand have completely simplified. So we're going to go ahead and move on to example 5. All right, looking at example 5, it looks like we need to find a group of 8 numbers that are the same. So off to the side, I'm going to go ahead and simplify 64. I'll be back in a second. All right. Okay, now I went ahead and factored 64, and it looks like there are 6 2's altogether. So I can rewrite that as 2 to the 6th power. That doesn't really help me much because I need 8 in order to simplify this radical. Okay, but at the very beginning of the lesson, I talked about the fact that we can convert this from exponential to radical form. So what we're going to do is we're going to go ahead and convert this over to exponential form. So the denominator is now our index, so this is going to be 6 divided by 8, which is going to just simplify. If you notice the exponent here is 6/8, which we can divide that by 2. So we're going to be left with 2 3/4. Okay, now because we initially ended up with a radical to begin with, we have to convert this back into radical form. So that means that our 4 is going to end up going as the index, so that's going to be the 4th root of 2 to the 3rd. Now we still have an exponent going on the inside, and I don't want the radicand to be an exponent, so we need to multiply 2 times 2 times 2, which is 8. So our final answer is going to be the 4th root of 8. And that's how we simplify that problem. Oh, let's see if I have anything. Oh, okay, so looking at example 8, this is also one of those simplifying problems where we have to take a look at the factors of 81, which are just going to be 9 times 9, and that's going to be 3 times 3 times 3 times 3. So we can rewrite that as 3 to the 4th power. Okay, now we still don't have 6 3's, so this is not a kind of an issue. But we know that we can convert it from radical form to exponential form, because another way to write 81 is just going to be the 6th root of 3 to the 4th. Okay, now I'm going to rewrite this as 3 to the 4 divided by 6, and simplify 3 to the 2 over 3. Okay, and then we rewrite it as a radical form, so that's going to be the 3rd root, okay, of 3 squared, which would be the 3rd root of 9. And this is where we would stop for this problem. Okay, now the reason why we need to rationalize the denominator is because we cannot divide by the square root of 5. So having a radical in the denominator is a big no-no, okay? So we can't leave it there. So the only way to get rid of it is to go ahead and multiply the denominator by the square root of 5 and the numerator by the square root of 5. And the reason why is because when I do that, that becomes 1. Square root of 5 divided by the square root of 5. Okay. So we're going to end up with the square root of 5 divided by the square root of 25, which simplifies just to 5. Okay, so we're left with the square root of 5 divided by 5. There's not a radical in the denominator. I've simplified the numerator to the best that I can, so this is as far as we can go with this problem. Let's go ahead and take a look at 8. Ooh, now we got 2 terms. Okay, so now with 2 terms, what we're going to do first is we need to take care of this 1 divided by square root of 3. Because we can't combine them yet until that radical is out of the denominator. So I'm going to go ahead and on this side, I'm going to go ahead and rationalize the denominator. Okay, and I'm going to multiply the numerator and the denominator. I'm not liking these 3's. Let's try that again. Okay, 1 divided by the square root of 3 times the square root of 3 divided by the square root of 3. Okay, and that's going to just equal 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3, which is actually the square root of 9, which is just going to be 3. Okay. All right, so that's simplified. So I'm going to go ahead and rewrite that as the square root of 3 divided by 3 plus 5. Okay, and that's all over 1. Okay, now when we're adding or subtracting fractions, we need to have a common denominator. The common denominator on this problem is going to end up being 3. So we're going to end up with the square root of, whoops, back up. Whoa, too far. This first fraction doesn't need to change because it has a common denominator, or the common denominator of 3 already, but we do have to multiply the second problem by 3 in order to have that denominator 3. So we're going to end up with 15 because 3 times 5 in the numerator. Okay, and now that the denominators are the same, okay, we can add the numerator. So this would end up being 15 plus the square root of 3 divided by 3. Now the next step is you need to go ahead and see if you can simplify any of the coefficients. Now there is a 1 in front of this radical, so that is already simplified. So 15 plus 1 divided by 3, that's simplified. You can't divide a 1/3 and make that a smaller value. You're done, okay? All right, so let's go ahead and take a look at example 9. Example 9 is a little unique because we have an index of 3. That's going to change some things up because we're going to go ahead and start off with multiplying by the third root of 2 in the numerator and in the denominator. Okay, so when we do that, we would end up with the third root of 4 in the denominator, okay, and the third root of 2. Now, if I break 4 apart, that's really just 2 times 2, and I need 2 numbers. Whoops, back up. I need 3 numbers inside the radicand to go ahead and simplify this completely, and I only have 2. So I need one more 2 in order for the denominator to simplify. Okay, as this let's back up. All right, so I need one more third root of 2 to multiply the numerator and the denominator by, so that the numerator is going to end up being the third root of 4 divided by the third root of 8. Okay, now the third root of 8, that just simplifies down. We're just going to end up with the third root of 4 in the numerator, and that's going to simplify down to 2. Because if I were to break 8 apart, that's 2 times 4 and 2 times 2, and we need a group of 3 numbers that are the same, and that does simplify down to 2. All right, last thing, double check to see if 3 and 2 can simplify. In this case, they are simplified, so that is it. We are done with this problem. We're going to skip that one, and that one's for the next video. Okay, thank you very much. And if you still have any questions about any of these problems, please come in for tutoring. I can help you out. Have a good day. Bye.